Okay, I'm going to do an example from the book, but before I do that, let's go over the rules in step 5. All right, so we've got a critical value method. That's what he calls it in the book, where we're going to use the critical value. So if we have a right-tailed test, right, we have a positive critical value up here. To reject, we need something bigger than our positive critical value. So in a right tail test, we reject if our test statistic is greater than the critical value, which is going to be positive. And a left tail test, we're going to have a critical value that's negative. So in a left tail test, we're going to reject the null hypothesis, just to be clear, if the test statistic is less than that negative critical value that we have. Right, I'm going to change this too, right? Reject the null hypothesis if. Okay, in a two-tailed test, we have two critical values. Right, we've got the negative one and the positive one, and we're going to reject in either tail. So in a two-tailed test, we reject the null hypothesis if the test statistic is less than the negative critical value, or if the test statistic is greater than positive critical value. Okay, so if the test statistic is less than the negative, greater than the positive, so either one of those we're going to reject. For the p-value method, here's the rule. If p is less than alpha, reject the null hypothesis. This is true if it's a right-tailed test, a left-tailed test, or a two-tailed test. Doesn't matter. All the time, this is the rule. So for the critical value method, we're comparing the test statistic to the critical value. For the p-value method, we compare the p-value to alpha. These two things are probabilities. These two things, the critical value and the test statistic, are distances from the mean measured in standard deviations. Right? So we can't compare the p-value to the test statistic. That doesn't make any sense. So this method looks really attractive, right? This is a lot easier to remember than all of this. But this p-value is only correct if you've entered it correctly in your calculator. Only correct when you put H1 in your calculator correctly. So if you're going to use this method, make sure you know how to do this. Make sure you know how to use your calculator. A helpful rhyme that I have learned in my adulthood, this was not how my father taught it to me, but a little rhyme I have learned says, if P is low, reject the hoe. So again, that's a nice little rhyme. It's easy to remember, easy to do. So make sure you're practicing putting this in your calculator correctly if that's the method that you're going to use. Now, I'm going to continue doing both methods when I do examples because some people like the critical value method, some people like the p-value method. If you want to just use one method, that's fine, but I'm going to keep on doing both of them just for the class so that everybody understands. All right, I'm going to do a problem from the book next. And I don't have the current copy of the book. This is the old edition, but you should be able to find it. This is number 18 in the old book from section 9.3. So if it's not exactly number 18, look for the one that talks about good credit and FICO scores. Okay, so, and this one's in the book. I'm just not sure it's number 18 anymore. The Fair Isaac Corporation credit score is used by banks and other lenders. Okay, that gives us some information about that. Blah, blah, blah. Let's go down to the question. Can the economist conclude that the mean FICO score is less than 720? Okay, so I know this is a hypothesis test question because it asks that can we conclude question. And let's work this out. So step 1, we're going to list both hypotheses. The question again is, can the economist conclude the mean FICO score is less than 720? So that's a mean less than 720. So the null hypothesis is that the mean is greater than or equal to 720. Step 2. We need to find alpha. So the end of the problem says use alpha equal to 0.05. So we're using 5% as our cutoff between likely and unlikely again. This is a mean, and we don't have a standard deviation, a population standard deviation, no sigma. So this is a t-test. If we have a mean, it's really always going to be a t-test. And we need to see if we've got a one-sided or two-sided test, if it's on the right or the left. So if I think about my alligator again, right, I can draw the alligator. This is a left-tailed test. Oh, not 720. Need to find the critical value. So degrees of freedom, let's see, n is equal to 100. So degrees of freedom is equal to 99. Look at the table. 99 degrees of freedom isn't on the table, so I'll round that up to 100. And area in the right tail is 0.05. So I've got 1.660 for my critical value. Okay. Step 3, I need to check the conditions. We need a good random sample or a good random experiment. We need n to be greater than or equal to 30 or a normal population. Okay, so let's go back and read the problem a little bit more closely. An economist wants to determine whether the mean FICO score is lower than the cutoff of 720. She finds that a random sample of 100 people. All right, so it looks like she took a good random sample. We'll say yes to that. N is equal to 100, right, which is greater than 30, so that's good. This one looks pretty good. All right, let's go on and compute our test statistics. So for step 4, we're going to put this in the calculator. This is a t-test again. This time we don't have data, right? So this is going to be input stats on the TI. And ask for mu sub 0, which is 720. Remember, that's the value of mu in our null hypothesis. So that's 720. It asks for x bar, which is 703. And a standard deviation from the sample of 92 and is equal to 100. And it asks for, right, mu less than, greater than, or not equal to. We want mu less than mu sub naught, right? The calculator is going to fill in this value there for mu sub naught, so we'll have mean less than 720. That's what we'd fill in on a TI. So on my Casio, I put the data as variables. This is less than 720, x bar is 703, x is 92, n is 100, and I get t equals negative 1.85, p is equal to 0.034. Okay, so now I need to go back and fix step 2. I put 1.66, but really this is a negative critical value, right? Because it's on the left-hand side, so that should be negative 1.66. And I want to compare my t-value, right? So on the left-hand test, if it's less than, right, t, my test statistic is less than my critical value. Therefore, I'm going to reject the null hypothesis. My p-value is 0.034, and that's less than alpha. If p is low, right, if it's lower than alpha, I'm going to reject the HO. So that also tells me I can reject. So this is my conclusion, to reject alpha. If I can reject alpha, then this is my conclusion. Right? The alternative hypothesis is my conclusion. And in step 6, I go back to the question, can the economist conclude the mean FICO score is less than 720? Yes. She can conclude the mean score is less than 720. And in step 7, it looks like everything is okay here. She has a good, it says she took a random sample. She has a big enough sample. I'm just going to put okay for step 7. Okay, one more thing before I leave this problem. She took a random sample. She found that x bar was equal to 703. So isn't that enough? Can't I just stop right here and go, yep, 703 is less than 720, so yep, that's what I can conclude. Well, no, that's really not what I can conclude, because this is a random sample. This is my sample mean. I can't compare a sample mean to a population mean just straight up, right? Because there's sampling variability in this number. I have to go back to my distribution, right, and look and see, here's all the values that would be likely to happen if the null hypothesis is true. And this value turns out to be unlikely to happen if the null hypothesis is true. So then I have some evidence that that null hypothesis is incorrect. But I can't just look at that sample mean and decide 703 is less than 720 and go, yep, okay, I'm good. Right? We can't compare sample means to population means without looking to see. Somehow we have to build a confidence interval either around mu or around x bar so that we can compare population means to population means. Okay.